We introduced unsupervised cross-domain image classification by distance metric guided feature alignment. We proposed a deep learning method for fetal ultrasound standard plane classification across images acquired by different acquisition devices. Fetal ultrasound is clinical routine for prenatal healthcare in many countries. Standard plane classification is important for the identification of possible abnormalities. However, images acquired by a different acquisition device have a different data distribution, which is known as domain shift. The problem of domain shift leads to the performance degradation of deep learning models. Our proposed method solves this problem and aims at improving the performance of automatic fetal ultrasound standard plane classification on a different dataset. In the proposed method, distance metric guided feature alignment is used to learn a shared latent representation space between the source domain and the target domain. Our method is an unsupervised domain adaptation method, where the inputs are the labeled images from the source domain and the unlabeled images from the target domain. Our method contains an encoder, a Gaussian embedding, and a classifier. The encoder learns latent features from input images. The Gaussian embedding extracts latent features with a Gaussian distribution. The classifier with a softmax is for the classification task. The reconstruction regularization and prior alignment are used to encourage the latent features of both domains to have the same fixed prior distribution, which is standard Gaussian distribution. The minimax entropy learns a single domain invariant prototype for each class and clusters the samples from the target domain across these prototypes. Cross-domain metric learning is proposed to maximize the margin between different classes within all images from both domains. Different from classical metric learning, where the metric loss is computed in a single domain, we compute the metric loss between samples from the source domain and the target domain. In addition, we integrate intra-class samples for the cross-domain metric learning. Class distribution alignment is used to preserve class relationships between the source domain and the target domain. Cross-entropy loss is used for the supervised classification on the labeled source domain. We evaluate the proposed method on fetal ultrasound standard plane classification task where images are acquired by two different devices. We first show the results of the proposed method and baselines. We observe that the proposed method outperforms the state-of-the-art domain adaptation methods. Compared to the fine-tuning and fully supervised method, where the labels of the target domain are provided during training, our method obtains a better performance on the target domain. In addition, we observe that the fine-tuned model is still domain-specific, as the performance improvement does not propagate back to the source domain. In contrast, our method improves performance in both domains and enables model generalization. We further explore the effectiveness of different components in the proposed method by removing different losses. Moreover, we show the confusion matrix and t-SNE plots of our method compared with a state-of-art domain adaptation method. We finally show the classification performance on switched domains, where device B is the source domain and device A is the target domain. The proposed method achieves the best performance. We also observe that the difficulty of the classification in the source domain can limit the performance improved in the target domain. Thank you for watching.